So thanks everybody for coming. My name is Mark Reederland, and I work for the Michigan Sea Grant Program. And this is one of the topics that we've been at. Sea Grant's been around for 50 years nationally, and the Michigan program's been around just a few years less than that. So we had to deal with high levels and work with bringing science to the shore back in the 80s. 6 years ago, we did a workshop like this, very similar with the people from the Corps of Engineers, and it was probably more like in March of 2013, and where the record lows. So now we're back in the high water regime, as you already know, and we'll hear a lot more details about that. So I want to say thanks to Northwestern Michigan College and the Great Lakes Water Studies Institute, who set up a room. Even if we had these awesome speakers like we have scheduled, if we didn't have a space to meet, we couldn't do a meeting. I'm just putting up the agenda for tonight, just to give you a flavor. We do plan on getting out of here by 8 o'clock. I have just like about 3 slides. We do have Lauren Fry and Deanna Apps from the Army Corps of Engineers. It's kind of our featured speaker number 1. And then we have Matt Gillen from the National Weather Service as one of our forecasters. I'll do more detailed introductions of them in a minute. If there's a hot question or two after each of the Corps of Engineers and NOAA National Weather Service talks, we'd be glad to take those. But if not, we'll hold the rest for kind of a facilitated question and answer time, which we'll have more towards the end, and we'll go home from there. So, well, thanks again for coming, and that's our agenda. We had a little bit of a media storm today, and I had sent them pictures that I took over in Graylickville of the same dock. This was January of 2008. Actually, that was not the lowest lake levels, but it was within 2 inches of the lowest lake levels, which happened in January of 2013. And I didn't have an exact picture of that, but I went out and took another picture on May 7th, and I just had them put together. That was the one in the winter lows, and then this is kind of where we're at today. So lots of water. Now, I just wanted to show one more slide to talk a little bit about simple math on the Great Lakes. So you're going to hear a lot more details from the people. We have these like 6 long-term gauging stations that account for the wind and the pressure, and they average all those out on a daily basis, and it's very disciplined data. It's binational. And so, but I just looked up the numbers. It's real easy to find from the Corps of Engineers website, and I picked February 1st. And the number in feet, you can put it in feet or meters, is 580.06. And then I picked just a couple days ago, it was 581.35. So you just do the difference. That's 1.29 feet. Or if you want to multiply by 12, you can convert it to inches at 15.48 inches since February 1st. Now they have to do the preliminary data, and some of those things are not fully finalized, but that's what's published. But I want to show that on there. And then for those of you that were riparians or around in 1986, 12 inches higher was the record high of all time that we have on Lakes Michigan and Huron. And that's 582.35. And that happened in the month of October, 1986. So we'll hear what the forecasters say. We're probably not going to get close to that in 2019. But as you'll hear tonight, there is a tremendous amount of water. Lake Superior is full, and it really kind of comes down our way. And it's going to take, we heard another talk just last week, and some other folks from Michigan Tech that study this very intensively. We're probably in a 2 to 3 year regime of higher water levels. So whatever we get this year, we'll have to see what 2020 is like, but there's a decent chance it's going to be high. So, so that's all I wanted to do really for my introductory comments, and just say thank you. If you do have questions, we do have some information on our MichiganSeaGrant.org webpage and on our Facebook page where we're sending this around. So Lauren Fry is our the lead water level forecaster at the Detroit district of the Army Corps of Engineers, and they have this office called the Hydraulics and Hydrology Office. And Lauren holds her master's degree and a PhD in environmental engineering from Michigan Tech, And she also worked, prior to working with the Corps, she worked at the NOAA Great Lakes Research Lab in Ann Arbor, where she did some postdoctoral research regarding Great Lakes basin scale modeling. So she's had that good background. And along with Lauren is Deanna Apps. Deanna is a physical scientist who's integrally involved, and probably going to be even more so in the future, with the Corps of Engineers and water level forecasting. So all the information that they have on the tables and the monthly bulletins that come out, they put some really good discipline to that, and Deanna is here with us to kind of co-present. And a little bit later, I'll introduce Matt Gillen from NOAA's National Weather Service office over in Gaylord. So I think at this point, I'm going to introduce and have Lauren come on up, and I will try and cue up your talk. So thanks for coming.
So thank you, everybody, for coming. I know that this topic is probably very important to most of you. So I appreciate Mark getting this together at short notice. We'd like to get the message out on water levels and the impacts around the Great Lakes. Can everybody hear me okay? I have a kind of a quiet voice. Okay. So I'm with the Detroit District Army Corps of Engineers. We're responsible for monitoring and forecasting water levels for the Great Lakes. I'm going to talk first. We'll kind of split this into two sections, with me presenting and then Deanna presenting. First, I'll give some background on what we do to monitor water levels on the Great Lakes, what actually influences water levels on the Great Lakes, and then I want to talk a little bit about the historical, give some historical perspective on water levels over the past 100 years. And so some of this is on the handouts that you guys have. That'll bring us up to the current conditions, and then I'll transition that to Deanna, who's going to talk about current conditions and what's ahead in the forecast. Okay, so everybody here knows exactly where they are in the Great Lakes Basin, so I don't need to talk too much on this graphic, but I think the graphic on the bottom left is interesting from the point of view of understanding the elevations and how water flows in the Great Lakes. So what that's showing is a cross section. You can think of it as a cross section from the westernmost point of Lake Superior to the easternmost point of Lake Ontario, and then out to the Atlantic Ocean via the St. Lawrence River. One thing that I want to point out here is this major drop. So you'll find that I'm going to talk a lot about Lake Superior, Lake Michigan, Huron, Lake St. Clair, Lake Erie. But this big drop here is the Niagara River. And so an important thing to remember is that the level of Lake Ontario, while it's impacted by outflows from the upper lakes, has no influence on the levels of the upper lakes. But when we're talking about the levels on the upper lakes, the levels of one lake, even if it's downstream, can influence the level on the upper lake, because it influences how much water can flow through the connecting channels. So if Lake Erie is high, that can influence the flow on the Detroit River. So it has some impact on upstream. So just bear that in mind. We're responsible for monitoring and forecasting water levels. We get our water level data coming in from Canada and the U.S. On the U.S. side, we get water level data from the National Oceanic and Atmospheric Administration. And those are the blue dots here on the map. And we get water level data from the Canadian Hydrographic Services and the green dots on the map. The two countries have determined a set of these gauges for which we feel that the average of those gauges is representative of the lake-wide average water level. So those gauges are shown with the light-colored ring around the dots. So on Lake Michigan and Huron, we have 6 gauges that Mark mentioned that we use to get our lake-wide average water levels. Another thing I want to point out on this slide is that it's important to remember that while I'm talking mostly about lake-wide average water levels, and in fact mostly about monthly mean lake-wide average water levels, the day-to-day variability that you guys actually see at your location can be significantly more. So we'll learn about some of the impacts of that day-to-day meteorologically driven variability from that. But But just remember, when I'm showing monthly mean water levels, what you see at your particular location can vary quite a bit from day to day and even across the lake. So for like on Lake Erie, you can have several feet of difference from the west end to the east end, depending on the setup of the wind on that lake. So Mark mentioned that you can get water level data from our website. We provide tabular data, so if you just want to know what the daily average data for the gauges, so for the 6 gauges that we use to compute the lake-wide average, and also the lake-wide average. So that's available on our website, which you should have the links on your handout, and if we ran out of handouts, I can give you a business card to get you materials if you contact me. So we track water levels on a daily basis, but we really record them on a monthly basis. We consider that to be more accurate to look at monthly data. This graphic is showing 100 plus years now of monthly mean water levels on all of the Great Lakes. And you'll find that as I'm talking, I always start with Superior because it's most upstream, and I end with Lake Ontario, most downstream. So that's just kind of the flow of information that I talk about. But it's really cool that we have 100 years of data to look at. That's not very common in environmental data. Any of you who work on environmental science know that. So we have 100 years of data, and we can see the variability over time. And some things to notice here are that, well, we can see obvious seasonal variability, right, which you guys are very familiar with. And on top of that, there's interannual variability from year to year. And what we see here is even variability on the scale of, on the order of a decade. So, like here, we're seeing a period of very low water levels. So this was a decade plus period of low water levels that affected this area. And Mark had that picture from Graylickville showing the low water levels. That ended in the end of 2012, beginning of 2013, with a record low water level here on Lake Michigan and Huron. So it also included a record low in 2007 on Lake Superior. Following that decade plus period of low water levels, then we had a really significant rise. So just in 2 years, 2 calendar years, we had a record-setting 2-year rise in 2013 and 2014. So that's what this narrow box is showing. I just want to point out that there's records in the past that we refer to still. The low water periods of the 20s on Lake Superior and low water periods of the 60s on Lake Michigan and Huron. And of course, the high water period in the 80s also, which I don't have pulled out here. And then more recently in 2017, Lake Ontario hit a record high in the spring and summer last year, partly due to high supplies on Lake Superior, but also due to high flows on the Ottawa River Basin. Okay, so what drives the changes in water levels? I'm going to talk first about kind of the typical seasonal pattern of water levels. So this graphic is just a generic graphic of water level. Could be any Great Lake. We have low water levels in the winter, a rise in the spring, high water levels in the summer, and then followed by a decline, especially in the late fall. On Lake Superior, it looks just a little different. The peak would be a little later, August, September. But in general, the lakes follow this pattern. Okay, so this pattern is driven by the meteorological conditions during those seasons. So in the winter, rather than having rainfall running off directly into the lake, you have snowfall accumulating on the land surface. It's not melting as quickly unless you have a really warm winter. And so it's kind of a time of accumulation and not static water levels as opposed to declining. Then in the spring, the snow melts and you get more runoff into the lakes. On top of that, the precipitation that comes down comes as rainfall instead of snowfall, and so it's running off more directly into the lakes. And so you have your spring rise, which is the period we're in right now. Following the spring and the summer, the energy from the sun warms the lake. You also have less rainfall and runoff coming in, so you start the decline, but the decline really picks up in the fall when you have really relatively warm surface waters. I know it still feels cold when you go swimming, but they're relatively warm compared to the cold air that's coming down from Canada, cold air that's coming in the basin. And so when you have that gradient between cold air and warm water, you really have a lot of evaporation. So that's what drives the seasonal decline in water levels. Together, we represent these processes as the net basin supply. So the net basin supply is the sum total of the precipitation directly onto the lake, plus the runoff that's coming into the lake from the land surface, minus the evaporation from the lake. So we call that net basin supply, and I'll probably use that phrase a lot during this presentation. That plus the inflows from the upstream lake, that's your total supply of water. And then you have your outflow from the lake. So if your inflows into the lake plus your net basin supply are greater than your outflows, then you have a positive change in storage and vice versa, or positive change in water levels. Okay, so we're going back in time to our decade of low water levels. Around here, this is a picture from Grey Lakeville here, same area where Mark showed a picture. You guys are familiar with the issues. It's hard to get to your docks. The boat launches are challenging. Navigation can't carry as much of their loads. There's more potential for grounding of shipping. Vegetation has a chance to grow on these exposed beaches. There's more requests for more need for dredging, and there's less ability to produce hydropower during low water levels because of low flows. Okay, so after that period where we were getting used to that kind of normal situation, then we started seeing this dramatic 2-year rise. Lake Superior rose 2 feet. Michigan Huron rose 3 feet just in this 2-year period. We had this was because we had a large spring rise, and the fall during the autumn was less than normal during those 2 years. And then after that, we continued to have high water periods, so things didn't go down. So what I'm showing on this graphic, and the two graphics to the right, each have a top panel. On the top panel, I'm showing the annual total net basin supply. So that's the precip plus runoff minus evaporation on an annual basis. And I'm showing the difference from average. So these red bars are below average, the blue bars are above average. So for Lake Superior on the left and Michigan Huron on the right. And then the bottom panels are showing the monthly mean lakewide average water levels. So it's probably no surprise that during periods of low supply, you have low water levels. Michigan Huron, it wasn't quite as consistent, but you had a lot more years of low supply than high supply, and so we had this period of low water levels. So 6 years in a row, Lake Superior has had above average annual supply. So that's from 2013 to 2018. Michigan Huron, 4 out of those 6 years have had very high net basin supply. So that's really what's driving the high water levels. The story was similar across all of the Great Lakes. I'm not going to show these graphics for those lakes because I'm interested in Michigan and Huron and maybe Superior, but we can provide graphics if you'd like. And Dee's going to talk about the consequences of high water levels on all the Great Lakes. So in general, we know there's a lot of impacts with high water levels that are very different from what you saw when you were facing low water levels. When you saw low water levels, you were concerned about access, your docks, your vegetation coming up on the beach, beaches kind of going out too far. Now we're seeing a lot of people with very, very significant concerns with erosion. There's always erosion that happens during low water, during high water. The processes always happen. What's different and important is that the process is happening closer to our infrastructure closer to where we live, closer to where we interact with the lakes. And so it's much more impactful. The erosion is much more impactful during high water levels. This picture is Lakeshore Boulevard in Marquette a couple of years ago during a wind event. So when we have these wind events, onshore wind events like this that can carry debris, in this case, because water levels were high, it can carry debris right up onto the road. So we're seeing damage like that. I think Matt is going to talk a little bit about SAICH events. Again, these happen during low water levels, but we hear more about them during high water levels. Ice jams also happen during low water levels, but when they happen at high water levels, there's more likelihood of impacts from flooding from those ice jams. So I brought us up to kind of the recent past. Dee's going to focus more on what brought us up in the past couple of years to the recent conditions and kind of walk you through the basin on what things are looking like and talk about our forecasts. Yeah, Lake Michigan has a much broader range of variability. It's partly because it's got a much larger basin area. So Michigan and Huron are connected at the straits, right? So we think of them as one lake. What happens on Lake Michigan happens on Lake Huron as well. And so that basin is very large, and so the net basin supply, the variability in net basin supply is much larger. Additionally, the variability that you see on the other lakes is, or on Lake Superior, for example, has only an outflow relay that's influencing its variability. So any variability in all the components of the water balance will influence the variability of the lake. Outflows from Lake Michigan are controlled by Mother Nature. Yeah. So yes, that's a good question. We don't control the outflows of Lake Michigan. There's control at the St. Mary's River. So there's some control on the outflows, but we can't control the water levels completely because the importance of that basin supply is so much bigger than the importance of the inflows and outflows. All right, thanks, Lauren. All right, so next we're gonna, as she mentioned, we're gonna get into some of the current water level conditions that we've seen. So before we dive in, I'm gonna go through each lake for this. And so I just wanna kind of briefly talk about this image up on the left and what you're seeing here. So those, the black bars in the middle here are the long-term average monthly mean water levels. The gray on the bottom and the gray on the top, those are your record high monthly maximum and minimums. The blue dots are what was actually observed. This starts back in May 2017 through the last months, and those are those blue dots. The black line is the daily levels. So you can see, from Lake Superior, we've been close to the record high monthly mean water level. And you can see after the very wet end of April to early May that we've seen a very sharp rise in water levels here. You can see that the daily level is currently above the record high monthly May value currently. This is this is probably as of the level from 2 days ago when I made the graphic. And then I'll just have a couple pictures on each of these slides just to point out some significant events that have happened over the last year or so. At Lake Superior, this bottom graphic, this was over Father's Day weekend last year. Over 6 inches of rain fell near Houghton, Michigan. This was some flooding near the Portage Canal. And this one was more recently in the fall of this past year. In October 2018, where areas of the Lake Superior Basin received over 4 inches of rain, and really strong winds caused some really significant waves and shoreline erosion near Duluth. And you can see this actually right on the map. In October, this water level went up 3.5 inches just in 5 days. So, water levels are changing. We report the monthlies with monthly mean values, but they're also changing dramatically daily when you get events such as that. And now to Lake Michigan Huron. So you can see for Lake Michigan Huron, we've kind of, we've been in between above average and, below record highs. And you can see recently we've just seen that sharp rise and, that daily level is now getting closer to some of the record high monthly levels. You can see this picture is from just probably a week or two ago.
near Grand Haven at Harbor Island, where you're starting to see some submerged docks there. And then this upper picture, which I'll also let Matt go into more detail later, there was actually what they call a meteor tsunami on Lake Michigan of last year in mid-April. And this is at Ludington. And you can see down here, you know, you can see the shoreline, you can see the breakwater, and then all of a sudden, 10 minutes later, you see this large wave, and that has to do with some, you know, quick atmospheric responses based off pressure and wind. And like I said, I'll let Matt go into more detail on that event, but it was a pretty significant event that happened. Lake St. Clair is also experiencing, you know, very high water levels. Now you can see that their daily level is also above the record high monthly bay level there. You can see some of the flooding conditions that this was from a couple weeks ago when you had some strong winds and everything pushing some of the water on shore here near Marine City. And actually, same location, but a few months earlier, you can see the impacts, as like Lauren mentioned, when we have high water and you have those ice jams that occur in the St. Clair River, it does cause some ice to spill over here on shore. And you can see in St. Clair in the daily water levels, you can see when the ice jams occur, you see the water level kind of drops because that ice jam upstream is blocking some of that water. Then on to Lake Erie. So again, you know, very similar story we've seen with these very wet conditions from the end of April into May now, and again, daily level has really skyrocketed, you know, over the last month or so, and again is above the record high from the monthly May value there. This also was the last few weeks ago, early May, when you had strong east winds, some flooding in southeast Michigan, when on the western shore of Lake Erie there with their winds. And then up here is a picture from earlier February 2019. The last Sunday in February was very windy in the Great Lakes Basin. Some of the strong winds here shoved some ice on shore, and it was a very dramatic phenomenon that occurred. And there are videos out there, and you know, if you want to see it actually happen, there's actually people who got video of that occurring. But you know, there's just a picture of that. The ice that got pushed on shore. And last but not least, Lake Ontario. You can see here the record highs back in 2017. And again, especially on Lake Ontario, I mean, you can just see this dramatic rise in daily water levels over the course of the last month or so. So really very wet conditions. This is some flooding from, you know, early May in Sackett's Harbor, New York. You can, you know, really a lot of water there. And then this also is from that same February event that caused some of that ice shove on Lake Erie, also caused what they were calling an ice house on the eastern shore of Lake Ontario with the strong winds and waves. The spray from the waves actually was landing on, you know, trees, cars, houses, and freezing on contact and causing a very sticky situation up here for people that homeowners in that area. And I'm just going to talk briefly. I always just like to throw in kind of what we've seen for ice cover this winter. This year, the Great Lakes Basin maximum ice cover was 80.9%. That's the highest we've seen since 2015, when it reached 88% about. This was right after, it was in March 9th, it was right after a fairly cold spell there in the beginning of March where we saw the maximum. So that's something that, you know, that plays into the overall, you know, variability as well. And then now I'm going to kind of talk more forecast. So we kind of went over some of the current stuff and some significant events. Now I'm going to talk more forecast. So when we do our forecast for the monthly bulletin, which is our 6-month forecast, we do that at the beginning of the month. And, you know, whoever the forecaster is on that forecast, you know, we're using some recent basin conditions. You know, we're using any type of meteorological or climate guidance that we can to, obviously, we want to make the best forecast we can possible. So I'm just going to talk briefly about the summer of 2019 climate forecast. It's issued by the Climate Prediction Center. It's out of NOAA. And so on the left is the temperature outlook, seasonal outlook for summer 2019, and then on the right is the precipitation outlook. And what you're basically looking at here is what these colors mean. So that orange on the temperature means there's a likelihood of above average temperatures. The blue means there's a likelihood of below average temperatures, and that white where it says EC, it means there's equal chances, meaning they're unsure if it's going to be above or below. And then on the map over here, the green is saying a likelihood of above, and the brown is showing likelihood of below, and again, white is the same. So you can see that on the temperature map, you can see that, on the eastern side of the basin, there's a likelihood that we're going to see above average temperatures, and then kind of the below average sort of clips the Lake Superior Basin, but just barely, and then you can see the southern portions of the basin are likely to experience above average precipitation. So those are some of the things we were looking at going into the forecast and things we'll be using as we go into the beginning of June forecast. So I'm going to talk about our forecast products. So we have three really main products. So first is the monthly, which I just described. We do that at the beginning of each month. That forecasts out 6 months. And if you have the handout, that's picture that you have there, that graphic. And then I'm going to zoom in on each of these individually later. So, and then we have the weekly forecast, which we do every Thursday, or sometimes goes into Friday morning, and that forecasts out 1 month. So it's the change from today or what's going to be tomorrow to 1 month from that day. And this is what that product looks like. There's a little paragraph at the top that talks about weather conditions. What happened in the last week, what do we think is going to happen in the week coming, and then a lake level condition paragraph that summarizes this table below, which tells you, the level compared to last month, last year, and then at this last line here, which, again, I'll show this more zoomed up later, but the projection out 1 month. And then lastly, we have a water level outlook. I listed as an outlook. It's not really so much a forecast tool. It's more of a scenario-based tool. We update those scenarios every 3 months, and those forecast scenarios go out 1 year. And that's what this product looks like. We kind of use this scenario as to answer what-if questions. Obviously, we're constantly getting questions from the public, and we try to pick things that, people would be most interested in. And what it really allows us to do is I'm gonna zoom in so you can see. So I picked Lake Michigan Huron just as an example. But as Lauren mentioned before, we have net basin supply sequences, which is your precipitation, evaporation, runoff. We have those net basin supply sequences that go back to 1900. So we have virtually 118 years worth of net basin supply sequences. And when we run that through our routing models, and we say, okay, we're going to start at the level of last month's level, what kind of water levels are possible given our whole historical period of record of net basin supply? And that's what that gray band is representing. So that gray band is representing the range in water levels that would occur given those net basin supply sequences for our period of record that we have. And then what we do is say, okay, well, what do we think people are interested in? So in this scenario in particular, these three green lines up here, these represent net basin supply scenarios that are characterized by a significant spring rise. So we were thinking, okay, if we do see a big spring rise with these wet conditions that we've seen, where do we think water levels are going to be? And those are represented by those 3 lines. And then these 3 brown lines represent net basin supplies that are characterized by a steep fall decline. So, hey, we're at high water now, but how quickly could we get down here? And, so that's kind of representing, how fast or, where could we end up if we do see drier conditions in the future. So that's on the web too, and you can look at the graphics for all the lakes as well, but I'm just going to keep it to Lake Michigan Huron for today's talk. So now I'm going to talk about the 6-month water level forecast. This is our main product that we do at the beginning of the month, and it reports out the monthly mean water levels and forecasts monthly mean water levels. So just briefly before I get too much into this slides, I just want to briefly go over kind of what's on the graphic. I know if you have it in front of you too, maybe you can even see it better. But this blue line here, this dashed line, is your long-term average monthly mean water level. The red line here is what's occurred, so the actual, what's been observed. These black denotations at bars at the top and bottom are the monthly max and monthly min values, and these are read based off of chart data. And so you got your feet on one side and meters on the other. Each of these lines represents about 2 inches. So just for if you're, to try to read the graphic. So obviously from the current conditions, we've seen that, the Lake Superior level has actually risen quite a bit from when we ran this forecast. So this forecast was created at the beginning of May. So, just keep in mind that we have seen, a decent rise in water levels so far in May. So, these things are likely going to, change, obviously, when we get to the beginning of June. So with the beginning of May forecast at record high level for record high monthly level in May for Lake Superior, and then 2 inches above record high levels in June and July, and at its record high level in August. So when we're looking at this, these numbers are based off of this green line, which is what we call our most probable, or the projected level, which is the dash green. This red bar here that's shaded is denoting our forecast range. So we're saying if really wet conditions occur, we'll likely see levels closer to the top of the band. If fairly dry conditions happen, we'll see levels closer to the bottom of that band. So that's what that band is representing. And so, as I've said here, the upper part of the range indicates chances for record high water levels throughout the next 6 months if wet conditions occur, which is denoted by this top line. And then the Lake Michigan Huron, you can see that our forecast for at the beginning of the month showed that the whole range is really still below record high water levels, but it's well above average. The projection is 25 to 26 inches above long-term average levels. But the forecast did call for 6 to 9 inches below record high levels through September. That's 17 inches below in October. So water level's still high here, but right now not forecasted to potentially reach records. So then this is for Lake St. Clair. If you remember from the current conditions, this is where we're already seeing daily levels above that monthly monthly mean max level. And so this forecast here forecasted to surpass record high 2 inches above record high level in May, and then 1 to 4 inches below record high levels in June to September, and then 12 inches below in October. And again, you can see from the band here that we still upper range indicates chances of record high levels through September if those wet conditions continue to occur. So, and then for Lake Erie, also a very similar story here. It was forecasted to reach its record high monthly mean May level, and then be 3 to 6 inches below record high levels through September and 15 inches below in October. I mean, looking at the daily levels, it's becoming more likely that Lake Erie will likely set a record in May. Obviously, we have to wait till the end of the month to know for sure, but given where the daily levels are, it's likely that we will probably be slightly higher than that. Again, the upper range of that band does indicate the potential chance for record high through September if we continue to see these wetter conditions. So. Last but not least, Lake Ontario. We saw that sharp rise on the current conditions, and you can see that similarly in the monthly forecast, where we are forecasting to rise quite a bit here in the next month or so before we start seeing that lake come down. Currently, the forecast shows 5 to 16 inches below record high levels. But again, here, the upper range of this forecast, does show chances for potential for record high levels if wet conditions occur in the summer. And then in the fall, the range does fall below record highs, and we're in between average and record highs there. Lastly, I just want to come back to the weekly forecast because we do this every week, and this is just to give us an update of what we think the projections are going to be out 1 month. this bottom line shows, this was the forecast done last week. This is our projection for levels by June 17. Lake Superior and Michigan Huron, we expect to rise 3 more inches by middle of June. Lake St. Clair be near its current level. Lake Erie should start to, Lake Erie usually reaches its peak around May or June, so hopefully we'll start to see the level come down, which is forecasted to be 1 inch below by middle of June, and then Lake Ontario continued rise of about 5 inches, and that's where you can get the forecast information at that link. And this is that contact slide. Those of you in the room have it as a handout. And
let me introduce Matt Gillen. Matt is from our Gaylord National Weather Service office. That's part of our National Oceanic Atmospheric Administration. That's in the Commerce Department at the federal government level. And I'm going to try and cue up his slides. And they do tremendous work for a huge geography that they have to forecast for, like from Sault Ste. Marie down to almost Ludington and over. So it's a huge forecast area. And so we will get his talk queued up here.
Well, thank you all for joining us this evening. We're going to kind of transition from talking about the last decade of Great Lakes water and sort of transition that into everyday weather and some changes that you can see on the Great Lakes, not only on a daily basis in terms of the water level, but on an hourly basis even, and what's causing some of that. Just a little background about the National Weather Service if you're not familiar with it. The Gaylord office is one of 122 offices across the country. We cover 25 counties there. Each of the county borders are an area that we cover. And at the bottom, we cover 13 marine zones. Each one of those little, if I can find the pointer here, each one of these little things is a marine zone. We do forecasts for 13 of those across 3 of the 5 Great Lakes, including Lake Superior and Whitefish Bay. We have 750 miles of coastline. That's more than any National Weather Service office in the Great Lakes or on the West Coast or East Coast. So that's a little interesting fact. And we have warning responsibility, meaning special marine warnings or tornado warnings, that type of thing, out to mid-lake of both Lake Michigan and Lake Huron. So here's a quick agenda. We've heard a lot about the water levels. We're going to just breeze through that in a slide or two. Once again, and then we're going to talk about storms on the Great Lakes. We're going to talk about specifically 2 different kinds of storms. We're just going to sort of gloss over the top of each of them so we can move through this presentation. We're going to talk about the enhanced problems that they occur and some flooding issues that arise from them. We'll talk about seiches and meteor tsunamis. Which are a little bit difficult to explain, but we'll do our best. We'll show you some animations and some pictures of those and some of the impacts that they cause not only locally here on the Lake Michigan shoreline, but also up in the St. Mary's River, in the Soo Locks, and all the transportation that goes through that area. Briefly cover rip currents, which are a growing concern, not necessarily occurring more often in the Great Lakes, but more well-known, more understood, and one of a big topic each summer in the Great Lakes. Then we'll cover some brief safety info where you can find some of this information on your own. We're going to skip that one. We heard a lot about water levels. This is one more. Just the red line is showing the 2019 level. The blue line showing the 2018 level. Again, you can just see that we're already higher than last year up to this point. All right, so let's kick it off with storms on the Great Lakes. Everybody is familiar with the wreck of the Edmund Fitzgerald back in 1975. Everybody from the Great Lakes kind of knows of that story. Well, that's the first type of storm that we're going to cover, a large area of low pressure, which you can see here on the weather map. You've all seen like a weather map on the late night news or anything like that. This is a picture from 7 a.m. November 10th, 1975. And what these storms produce, or what they're known for producing, are prolific winds, often from the same direction. And in this case, here in Traverse City, you'd have basically a west or southwest wind. And we're going to connect this to a seiche event. So keep these types of events in mind where you have prolific winds for anywhere from 12 to 36 hours in time. You're going to have wind from the same direction, almost pushing water in one of the Great Lakes over to one direction. Just keep that in mind as we move forward and talk about seiches. Another example of this is the Great Lakes hurricane of 1913, a little bit further back in time. But that was one of the greatest storms in the Great Lakes in terms of fatalities. A total of 258 people, or mariners, I should say, perished in that event. and gusts as high as 90 miles an hour and waves as high as 35 feet were recorded in that storm. All right, so then we covered these large-scale wind storms that so frequently happen in the Great Lakes region, especially in the fall. And then there's another type of storm that we get on a much smaller scale. Those are thunderstorms, or severe thunderstorms especially. So this map is showing the average number of thunderstorm days across the country per year. So to describe it a little more, most of Michigan, except for the very northern part of the UP, is between 30 and 40 thunderstorm days per year. That just means a thunderstorm was observed on a day. It doesn't have to be in a given location, but somewhere in the state, 30 to 40 times. You can see the hotbed is down here in Florida, and you'll see why on the next slide as we go ahead and talk about that. So we need three things for thunderstorm formation. Three ingredients. And the first one is instability. When air is heated, it becomes lighter and rises. It's less buoyant. It wants to move up, right? How is a hot air balloon, how does that work? They heat the balloon, right? It rises. The same thing with boiling a pot of water. You're going to get the steam to rise. So hot air wants to rise. That's our first ingredient, is instability. If there's enough moisture present, which we've sure got a lot of moisture around here, right, with the Great Lakes surrounding us. And of course, we can draw moisture up from not only the Atlantic and the Gulf of Mexico, but also from the Pacific Ocean as well on a much larger scale. So if we have enough moisture, you're able to develop clouds and what's called an updraft in a thunderstorm that's going to sustain that cloud and that storm. And then third is a source of lift, which often acts as a kickstarter to a thunderstorm. And most of the time around here, it's either a cold front, which everybody's familiar with, or a lake breeze. And that's very common this time of year where the winds come off of the lake during the early afternoon to late afternoon, and that can act as a source of lift for thunderstorms. So we've covered the three ingredients. Now there's three basic types of thunderstorms. Single cell thunderstorms, which is your garden variety pop-up thunderstorm in the afternoon. You've got a multi-cell thunderstorm, which is what we're going to focus on today in just a couple of slides. And then a supercell thunderstorm, which is often seen out in Oklahoma, very picturesque, and produce large damaging tornadoes. All three of these they certainly can all happen in Michigan, but one of them is much more common in terms of the damaging storms and what's going to affect those day-to-day or hour-to-hour lake levels on the Great Lakes. And those are multi-cell or squall-line thunderstorms. A little bit of more information about these thunderstorm complexes do the majority of severe weather damage. How many folks are familiar with August 2nd, 2015 in terms of severe weather? Almost everybody being from this area, that's good. We're going to cover that very briefly. It's one that if you've ever been to a National Weather Service talk you've heard about before, you're going to hear about again, because it's the best example that we have locally to show you not only the damage that these storms can produce, but we'll just flip to the next slide you can watch. So this is a radar image from, the radar is right here just south of Gaylord, and you had 4 lines of severe thunderstorms that moved through northern Michigan that day. The first one was across the tip of the Mid. This will play again. And there's the big one there, which we'll cover. Let's let this restart. So the first one's going to be across the tip of the Mid. There's going to be a second wave that moves sort of along the M32 corridor. There's the second one there, and then the third one is going to be the one that impacted Glen Arbor, right here, Glen Arbor, and Traverse City, of course, down M72 all the way towards Lake Skegama. Let's see here. So this is a view of the thunderstorm that day here in Traverse City as it moved. Anybody familiar with that cloud? Anybody see it that day? Yeah. Yeah. So that's sort of the signature cloud of the multi-cell thunderstorm. And if you can imagine these thunderstorms, if we go back a slide, if you can imagine each of these thunderstorms, these complexes, these lines of thunderstorms are moving anywhere between 50 and 70 miles an hour to begin with. And the amount of momentum that each of these is carrying, and as that wind sinks down from the sky towards the ground, it can't go into the ground, so it's got to spread out as it hits the ground, right? The amount of momentum that those are carrying can often shift the lake levels on an order of significant amounts in a shorter period of time. And we'll see that when we cover seiches and meteotsunamis here. So we've seen that. I don't know if we have sound. Mark, do we have sound on the video?
I don't know that we do,
no?
but you can try it.
Let's try it and see.
Yeah, see if we can find the volume.
Let's try it again. So this is a view from Lake Speedwalk. Just down in that day.
We might need to switch the display settings one more time. Yep.
Uh-oh. Uh-oh. There we go.
What? I know, you gotta watch the tree.
Where we need audio, that's us giving out the
Oh, yeah.
Wow. Go on the news,
So, as you watch that film, you can definitely hear the way, almost at times hear the pressure changing on that video, just the crackling going on in the background there. And that's really just to show the momentum that these storms pose.
Can I make a comment on that?
Yes.
We saw that. That was.
Yep.
What intrigued me, it was pretty much a higher elevation.
Yep.
There was no wave in it.
Yep.
All the trees are all high trees, high canopies.
Yep. Yep.
That was one that all knocked down.
Right.
Ground.
Yeah, almost chopped off halfway down.
Most of the boats were fine.
Yeah, right.
Very weird.
Yep. So this is an example of a, let me go back here. All right, meteo tsunamis. So we're going to kind of relate those severe thunderstorms, those squall line thunderstorms, and relate them to meteo tsunamis. A meteo tsunami is let's see if we can get this to play. All right. If you watch this animation here, it's a very chaotic wave animation of what a meteo tsunami is modeled to look like. The dark blue would be the water in the Great Lakes, for example. So meteo tsunamis are not triggered by seismic activity like you hear about a tsunami in, that's going to hit Hawaii or Thailand or any other location out in the Pacific. These are driven by air pressure changes, often associated with fast-moving weather features, such as a squall line thunderstorm. Meteo, the prefix to tsunami there, means meteorological. It's caused by a meteorological event. And these generate waves. Let's play that one more time. All right, soft play once, I guess. They're typically short-lived. They range from generally on the matter of minutes to no more than a couple of hours. A meteo tsunami example on the left there, you've got this is from April 13th of last year. You've got a complex of thunderstorms that moves through a portion of northern Michigan. And watch here on the, let's see if we can get that to play. On the right side, this always works until you get up here. Okay, well, at the very least, what you would have seen was these red colors here are a much higher water level, or essentially a wave, and they would be rolling basically at the same time as these thunderstorms being pushed up towards Ludington and Manistee. In the next picture we're going to show you, you've seen it earlier, but during this meteo tsunami, the large rise or the rapid rise in water, only for 10 minutes later to be back down to its normal level. You can see the pier and everything. This is that same day. This is the National Weather Service equipment down in Manistee, the wind site there right on the water. That's what it looked like afterwards. The concrete block was actually lifted completely out of the ground. And that still hasn't been fixed. It's going to be fixed this summer. And this is the Manistee River there. Also, water was flooded up the Manistee River. So those are large producers of damage. On the other hand, let's think back to those first types of storms, the large windstorms that have 12 to 36 hours of prolonged sustained winds in the same direction. They're more typical of causing what's known as a seiche, and that you can think of this bottom right-hand image, sort of a sloshing back and forth. You ever seen water slosh in a bathtub? It's very similar to that, just on a much grander scale. If you think of west to east from Green Bay, towards Traverse City and the Great Lakes, it's going to take hours or even days for that to come to an end. But, so when you've got a sustained strong wind, let's say you've got winds coming out of the west for 36 hours, and all of a sudden they stop or they switch to the southwest or they switch directions, you've got all that water that was piled up for 36 hours right up, say, along Manistee to Frankfort up towards Leelanau County, and that water is going to start sloshing back. So you're going to see a rapid decrease in water, and only to see a rise in water as you head towards Green Bay, and that's going to slosh back and forth as similar to the bathtub, like I mentioned. So it's often difficult, especially as our water levels are higher than normal, on the difference between what a seiche event is and whether it's just high waves or high water levels. It's much easier to distinguish these things when we have low lake levels. And here's some examples of that. Leland on May 6th, just the week of May 6th, 2 weeks ago. Now, whether this is a true seiche event or it's just due to high water, it's a little hard to tell, but everybody's heard it. I don't know if you have.
It went in and out about 11 times.
Okay,
that
so
day, and it was actually
probably
that much
talking
higher
about
than that building.
yeah, you're probably talking about a seiche event if it's going to go in and out like that. But nonetheless, this is Fishtown in Leland there, and as the water levels continue to rise, there's only going to be more issues of these sorts, especially in that area. Another example of this was on October 20th of last year. This is when we had a due north wind down the bay for, I think it was a day and a half or 2 days. And the waves that were piled up there, that's open space, that's the Indigo Hotel, right behind it there. Just phenomenal amounts of power and amounts of water that can be sloshed back and forth. So another example of this, if you're not familiar with the St. Mary's River system, it connects Lake Superior down to Lake Huron. There is a lot of ship traffic and a lot of commerce that passes through there on a yearly basis, on the order of billions of dollars of commerce. And if you can imagine one of these seiche events happening in the locks, and all of a sudden a bunch of water, while they can control that to some extent if they're not prepared for it, a lot of water can sort of be sucked out of the locks and the boats end up grounding, and there's no way to really move them until the water levels rise and they're able essentially floating again. So of course there's headlines every so often, every couple of years about that information, about the locks and the effects on seiches. And one thing the office here in Gaylord, the National Weather Service, is trying to do, working with the Sioux Locks on trying to come up with a better way of not only forecasting seiche events, which affect them so greatly, but alerting them as well. So just to recap, you can kind of compare the two, the chaotic nature of a meteo tsunami and the damage it can cause versus a seiche event, where it's often more methodical and waffles back and forth like a bathtub. Remember, meteo tsunamis are sort of more thought of with severe thunderstorms, quick moving disturbances, weather disturbances, while a seiche, think of the gales of November, the powerful winds that last for hours and hours, if not days. So rip currents becoming much more prevalent, or at least aware of, in the Great Lakes. Of course, swimming on the Great Lakes is fun, maybe not today as the water's still quite cold, but as we head into the rest of the summer, there's always people on the beaches. Each year, the Great Lakes sees an average of 12 rip current-related fatalities and at least 25 rescues. And since 2012, there have been over 450 current and wave-related incidents on the Great Lakes. So if you think of the Great Lakes versus an ocean, the waves come in a lot closer than ocean waves. You can see here in this image just an example of it. Every 3 to 5 seconds on average, a wave is crashing into the Great Lakes. It's a little bit faster than what you'd see on an ocean where maybe you've got 5 or 10 seconds between waves. So if you're knocked down by a wave, the next one's right on the heels of it. You don't have a lot of time to get up and get out of the way. Dangerous currents form along sandbars, near shoreline structures like piers, and of course near water outlets like the river mouths. A good example of that is the Platte River, mouth of the Platte River that empties into Lake Michigan. And dangerous currents are more likely when waves are 3 feet or greater. So you can see here signs of dangerous currents. I know you'd have to be sort of above the Great Lakes to see this first example here, but the muddy or sandy water that's coming from the shoreline being pushed out into the Great Lakes, that's a great example of this little break here is a great example of a rip current. Here's one that's you maybe see a little bit better from the actual shoreline, a break in the waves. If you think about it, you've got waves coming at you, you're standing on the beach. That break right there, there's water actually going the other direction. So it's essentially a small 50 to 100 foot wide river that's going the opposite direction of the rest of the water. So there's 3 steps to safety. Here's a great image of it. This is from Berrien, Michigan, an overhead view of a rip current. So of course everybody's natural, if you're swimming in the Great Lakes, all of a sudden you end up 100 yards from shore, your natural instinct is to panic. How did I get this far away? Key is to stay calm and swim to the side. These rip currents are usually only 50 to 100 feet wide, so if you swim to the side and you no longer feel that force kind of pushing you away from the water or away from the shore, then you can sort of know you're out of it and you can start heading for shore. Don't tire yourself out trying to swim right back down that rip current, because it's not going to go well. And the key to all of this is know before you go. Check the National Weather Service beach forecasts. Not only do we in Gaylord, but every Weather Service office that borders a Great Lake has a Great Lakes forecast. The website is right there, weather.gov/Great Lakes/beach hazards. And every day there is a swim risk assigned to each one of these forecast areas. And they just started on May 20th for this year. And they'll go all the way through the end of the swimming season, typically late September or early October. Green is low, generally safe conditions, generally safe, still use common sense and caution if you're going to swim in the Great Lakes. And then red is life-threatening conditions, and we urge everyone to stay out of the water on those days. Do we have any mariners in the room? Anybody that likes to boat on the Great Lakes? Okay, for all of you folks, this is something that's relatively new. The website here is at preview.weather.gov/EDD. And if you change the interface to travel, you can right-click on anywhere on this map. It's not just Northern Michigan related, it's anywhere in the country. But if you right-click, say here at the Clinch Park Marina, and you want to take a trip to Frankfurt tomorrow on your boat, you're going to right-click for your start location, right-click for your end location, press go. The next little window that's going to pop up is going to ask you when you're planning on traveling. You select your date, the time that you're going to depart. You select the average vessel speed that you're going to be traveling at. And along that route, it is going to give you personalized forecasts based on the timing of your trip. So all these forecasts are put together and use them. They're there for everybody that's out on the Great Lakes. And they're going to have information such as wind speed, wind gusts, the direction, and then your maximum significant wave height.
Yeah.
I can, yeah. It is preview.weather.gov/EDD. Yep. Some other information, your local National Weather Service page, weather.gov/APX or weather.gov/Gaylord will get you to the same page. There's that website we just talked about, the Great Lakes Beach Hazard page. And if you want more information on rip currents and safety, that would be found down there in the bottom right. So that is all I have. The question was whether there were tornadic circulations on August 2nd within that storm that moved through. There wasn't any documented tornadoes with that day, and it almost, from a meteorology standpoint, you almost wish it was a tornado because the amount of damage would have been so much smaller than the amount of damage that we saw. That widespread 50 or 100 mile wide path of damage would have only been a quarter of a mile or half a mile wide in a tornado.
Beaches are definitely going to be changing. Again, we've heard a little bit about the static water levels and then the storms on top of that. That's where a sustained storm, maybe 1 or 2 storms might do 97% of erosion damage, for instance. So it all depends if you get that couple days storm where everything just keeps coming. We had an example coming out of the north here in Traverse City. That was a sustained wind. So, but beaches are going to be different. I just wanted to comment that kind of our sugary sand that we like on our shore, we see a lot when we have lower levels. That's all buried now underwater, right? This is really light, fine sand, and it's very mobile in the water. So it is already underwater. And it's going to be moving up and down the lakeshore. It's going to be forming the sandbars out at various places. So even in, for water safety issues, for swimming, We want to tell everybody to be extra careful on the sandbars as it relates to maybe a rip current, but just even as you get out there, the sandbars are going to be higher and a deeper trough in between. So sometimes there's 2 or 3 or 4. So just pass it on to your families. And again, we're just trying to educate people so they enjoy and have a good time in the Great Lakes and no issues, no serious issues of injury would happen. So I just wanted to make that comment on the beach sand really being mobile and moving now, and we're kind of left with a coarser sand and some rocks that are heavier and they're harder to move. Thank you for putting up with a crowded room.